Okay, welcome back to our part 3 of our video on solving rational equations and inequalities. And so I thought that we would take a look at this first couple together because these 3 examples do kind of highlight some things. Hopefully you've had a chance to take a look at them and you'll kind of see what I was talking about as we take a look at it. So for this first one, we're going to start by doing the same thing. It's already got 0 on one side. I'm going to try to factor, and the first thing we'll realize pretty quickly is that this factor is prime, does not factor. That does not mean that I can't solve it. It simply means that I cannot factor. It doesn't factor nicely. And typically when quadratics don't factor nicely, then we have other techniques for solving, including the quadratic formula and so on. So I am going to find my critical points when I'm at this point. I'm calling this one f of x. So f of x equals 0 when the numerator equals 0. And so the numerator equals 0 easily at x equal to 3. So we add that in. Then we take a look at the denominator, and we are going to have to solve for that. So f of x is undefined when x squared plus 4x plus 2 equals 0. So I'm going to solve that using the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. Let's simplify this down. This would be negative 4 plus or minus, what do we have? Square root of 8 over 2, negative 4 plus or minus 2 root 2 over 2. And I like to simplify negative 2 plus or minus square root of 2. Now, in terms of numbers, we might not have a calculator as we're doing this. It really should not bother us that we don't have a calculator because we know that the square root of 2 is something between 1 and 2. So we know that if I was doing an approximation, this is negative 2 plus or minus 1-ish, which I love my math technical terms there. So if I was looking at it like I'm putting it on a number line, which is going to be our next step, I'm going to put my sign chart over here. Negative 2 minus 1-ish is a negative number, negative 3-ish, okay? Negative 2 minus square root of 2, approximately negative 3-ish, just to kind of get an idea of where it is. Negative 2 plus square root of 2, when I only add 1-ish to a negative 2, I'm still negative, okay? So negative 2 plus square root of 2, it's something like 0 point something-ish. Okay, just to kind of give you an idea, but it's still a negative number. That's kind of my key, because when we pick test values, you kind of have to know where you are. And then out here is going to be the 3 that we have. Put your 0, your undefined, and your undefined there. And then you're going to run your test values. And the reason why I wanted to show this to you kind of in more detail than just asking you for questions is that, like, if I'm testing clearly in between, you should always just test the negative 2. That's why I simplified that down to a number plus or minus something, because then we know that the number negative 2 is always in between. I don't have to really guess about it. I don't even have to do that it's negative 3-ish and negative-ish, because I know that the number negative 2 is always going to be the number that's in between. So I just thought I would mention that. Down here, I always test something like negative 10. Here, the nice thing, once I realize that negative 2 plus square root of 2 is still negative, I'm going to test, and it's probably, I shouldn't write it right there. Let's kind of squeeze it in here. I'm going to test 0 there, and I'm going to test 10 there. So why don't you guys go ahead and do the plug and chug, run that in, and get the plus or the minuses that should go in the sign chart. I'm going to ask you a question about that. All right, so you guys should have gotten your alternating signs, minus plus on that. So let's go ahead and answer the question. They ask us in this problem that we wanted greater than or equal to. So I'm going to highlight that, and I'm just going to make a note. So that means I want the positive and the 0 from the sign chart. And so when I go down here to the bottom and I write my solution, My solution would be positive and 0 parentheses, -2 minus square root of 2 to -2 plus square root of 2. I want positive and 0, union, bracket, 3 to infinity. And so I just also wanted to kind of show you that when we take a look at that in Desmos, so I did Desmos over here just so we could see, make that connection. So we see that where we had the negatives, we're below, positives above, negative below, positive above. We can see here that we do have a 0. I click on it at 3, 0. And I went ahead and stuck in just vertical asymptotes at -2 plus square root of 2 and -2 minus square root of 2. So you can kind of see here in this graph, see how it's approaching those vertical asymptotes and going straight up and then approaching it down here on the bottom. So that's something important to take a look at on that one. So that one was interesting because to get your quote unquote critical points where your function was undefined, you actually had to use the quadratic formula. All right, so let's go back to our OneNote. And so I'm going to let you guys revisit the second one, and I'm just going to pop up some questions for you on that to answer, and then I will show you the key in a moment. All right, so coming in and taking a look at this, really the only interesting thing about this, and one that I hope you noticed as you were doing this problem, is that when you were doing your test, okay, we got our credit, it was very easy, it was already factored, it was already 0 on one side. When we were doing the test, even though I was picking these values and plugging them in, hopefully you realize that the only factor that mattered was the 2x plus 1, that the squares here and here in the fraction, that when you square something, a squared number is always positive. So in terms of the sign analysis, SIGN, you really only had to look at the 2x plus 1, which is a line with a positive slope. So it should be negative before the -1/2 and then positive after that. So it makes it very quick to fill in the signs here. A lot of times we go for what I call shortcuts instead of plugging numbers in. I kind of do an analysis that's a little separate. Even though the plugging and chugging is always an option, it can be tedious. And so we do want to make sure that we look for shortcuts like we have in this one. All right, let's scroll down and let's take a look at the last problem in this set of notes. Now, the one thing that's interesting about this one is that we don't have 0 on one side. And so to start this problem, and I did mention that in the previous video, but the first thing we're going to do is we're going to get everything on one side. So I move the 2 over x minus 1 over by subtracting it. And then once I get this to this side, what I need to do is I need to get a common denominator, and we need to add those together. And so I'm going to let you kind of go back and revisit that. I'm going to ask you some questions in the video, and then we'll come back and discuss the things that we want to over that. So practice getting a common denominator and combining the fraction and then factoring it and going through the process of the sign analysis. All right, so coming back in, getting our common denominator, I multiplied by form of 1. Remember, that's your rule for common denominators. So I multiplied each fraction by a form of 1. My common denominator was the x plus 2, x minus 1. When I got the denominator was factored, so I didn't multiply it out because remember our objective in the sign chart is to have it in factored form. So when we look at it, the bottom I left, but now the top, we had to employ the method that I call in calculus sledgehammer, which meant that it was not in factored form because of this minus right there. And so when we were looking at that, sorry, so when I was looking at this factored form, this minus messes it up. So I went ahead and sledgehammered, which is distribute and then collect like terms. And so I'll leave the arithmetic to you, but we basically distribute and I get this x minus 7. And then so now you can go in and this is what I am considering. Like I'm thinking of this function over here. Once I get it all on one side, and I'm thinking of this as my quote unquote FRED, my reduced function, and simplified. And I'm going to use that to do my sign chart. So I tested -10, 0, 2, and 10, plugged into this version right here, because that really is the better one. The nice factored form is the easier one to plug in to test the values as I was looking at it. And then I basically looked over here to this side as well to determine what I wanted, which is that I want less than or equal to 0. So I want the negatives and the zeros. And that allowed me to, when I did my solution, to know that this needed to be a bracket on that 7 because I was including the zeros. And also, if I go ahead and fill in terms of like shading it on the sign chart, it would look like this with a closed circle on the 7 right there. All right, so that wraps up our notes on a review of solving rational equations and inequalities. In inequalities, make sure you are using a sign chart analysis, getting your critical values, and making sure that you kind of go through this process each time you're solving that inequality. All right, we're going to stop there. The next set of notes is on the intro to the graph rational functions, which we've already seen in Algebra 2, but we're going to review that for this year.